Hey, welcome everyone to today's Ask Me Anything session with Eternity Crypto Foundation's core developer team and middleware team for the first time now for the first quarter of 2023. So I'm really pleased to have you all here just to share again the participant list. We have Dimitar, we have Ulf, we have Metin, Sean, Sebastian, as well as Rogerio for the first time also. So yeah, uh, thank you guys for being here, and Dimitar, feel free to start.
Hello. Yes, our group is growing, and that's great. So let's share what we're planning for the next quarter. This is our agenda. We're about to talk about Hyperchains, garbage collection, network monitoring tool, the mesh protocol, the plugin and system and dev mode, the middleware, and new JavaScript SDK. So without further delay, let's discuss Hyperchains. Basically, our current state is that we're almost there. We have a relatively mature smart contract where our nodes are consuming entropy from the parent chain, and they're also producing commitments on the parent chain. Uh, the staking and staking UI is in a really good shape. Um it also has functionality so stakers validators can change their names and icons and stuff like that, so it feels stable and mature as well. We have a script that generates the chow chains config, so you don't have to do that manually. It creates accounts, it creates basically anything you would need to start the local hyperchain version. So what we're doing for this quarter is that after commitments are being posted on the parent chain, we're consuming them back. And we have to feed those to the smart contract. And this is work in progress. After those are fed to the smart contract, we're going to elect the leader according to the who committed, who participated in the commitments. And based on that, we'll also be able to compute difficulty of the fork, and we'll have fork resolution finally. And that would make the hyperchain feature complete. Then we'll have to add some polish to make it production ready. We also need to improve the test, and there is work being done in regards of providing Docker Compose setup. The idea is that we have the script that produces the config, and we'll have the Docker Compose. So the idea is that the script is going to feed the Docker Compose with the setup required, and with a single or a handful of commands, you'll be able to start your own hyperchain, and it's going to come batteries included. So it's going to have a parent chain. So this is how you start your test hyperchain. It's going to have a parent chain, two explorers, two middlewares, faucet for the chow chain, uh, and the wallet. So everything you would need in order to test the locally hyperchains. Still, our goal is not to provide the full feature complete. Is to provide the full feature complete hyperchain, but it will not be production ready by the end of the quarter. So stay tuned. We have a lot of great news there. Now I'm passing the ball to U, who is going to talk about our plans with regards of garbage collection.
Yes. So just to describe what we have today, as you may know, the state trees for contracts, calls, accounts, and everything are in what's called Patricia Merkle trees. For each block, you have a top hash from which you can reach all the live nodes for that block height. So all the other elements are still in the state tree. So you can go back, say 1,000 blocks, and then you can find all the live data at that particular height. So, but of course, this means that database keeps growing. So right now we have garbage collection of accounts that you can turn on in the config. And the way that works is that at regular intervals, we start a full sweep at some height. And for all the reachable state tree nodes leaves at that height, we copy them to a cache. And then for every subsequent height, we keep updating that cache with the new data that comes in. And then at a certain point, we clear everything that is not in the cache and create a new state tree from that cache. Now, this has various drawbacks. Obviously, we're wasting space. It's also a bit IO heavy. So we're only doing this for the account tree. So what we're doing now is we're switching to a new model where for each tree, we have 2 database tables. In RocksDB, those would be column families. We call them here A, B, where A is the currently active copy. And anytime we update the state tree, we write directly to the A table. If we look up, then we try finding the node in the A table first. If it's not there, we look in the B table. If we find it there, then we copy that from B to A, so that anytime you touch a node in the tree, it's automatically promoted to the active copy. And then at a certain point, we can switch, and then we just clear the B table, because then at that point, it only contains old data. And then we make the B table, now empty B table, the new active table. And then we start writing to that and promoting. So what we then have to do is we have to start a full sweep to make sure we touch all the nodes that are live at the height where we made the switch, so that they are automatically promoted to the new active table. Now, we intend to do this for all the trees, which will give us a very nice small database. But of course, that's a whole lot more garbage collection than we're doing today. But with this method, we can throttle these full sweep traversals so that they are done in the background and don't affect overhead so much. Now, overhead, that would be mainly during sync, obviously, where the IO system is close to saturation. So once the traversals are done, and we have reached the minimum history length, which could be, say, 1,000 blocks or something that we want, 1,000 generations that we want to keep data for, then we can do a new switch. And then we just iterate that way. Now, the code is pretty much written. I'm fixing to start testing it, and then we'll see how that goes. But at least at this point, I know of no outstanding issues except that it needs to be tested.
Okay, now I'll briefly explain the network monitoring tool. We'll be writing a JavaScript-based tool that sniffs the network for how many nodes we have, possibly if they report that, which version they're running on, and so on. And we want to build sort of a topology tool to inspect connectedness, how well nodes are connected in the network, and if ions are forming and stuff like that. Currently, we don't have that, and it's a shame we don't still. But this we will be working on this this quarter. I don't know if we're going to finish that, because Dinchu is going to be working on that, and Dinchu is our DevOps / JavaScript guy who has a lot to do, and we don't know how much time he will be able to dedicate to that. Once this is done, we can try playing around with different setups on our mainnet and see how it reacts. Now I'm passing the ball to Sean, who is going to talk about the MES protocol.
Yeah, so as a core team, we're always looking at ways to increase the safety of the chain. One of the weaknesses of all proof of work chains is that they can be susceptible to 51% attack. And that's true for Eternity as well. So one of the things we're now looking at is a mechanism which just makes the typical 51% long-range attack much more difficult. So typically in an attack, somebody will create a private version of their chain, which may contain a double spend attack or some other attack on the network. And then by using much more mining power, they will be able to replace the main community fork or the main community chain. So various of the other blockchain projects have looked at ways to make it much more difficult for an attacker coming in to the majority of nodes to actually replace the main community fork. And one of those is MES. It was come up with by the ETH Classic team. This is live with in ETH Classic today. And the idea of it is that an attacking fork, a 51% attack, the longer the fork, the longer the attack is, the much more difficult it is to attack the chain, even beyond the proof of work difficulty. And it does this by simply rejecting incoming forks with difficulty with a multiplier. So the difficulty needed to attack the chain is multiplied by an additional factor based on the distance from the top. So we think that something similar could be quite useful for the Eternity chain. In addition to existing, artificial finality mechanisms that we have in place to protect against this, we think we can probably do more. This seems like a good one. We've done some initial investigations and started work on a prototype. During this quarter, hope to see, exactly how and in what way something like this could be applicable to the Eternity chain. So that's ongoing work. Thank you.
We should probably mention about the plugin and the DevMode, which are sort of feature complete, but in this quarter, if we have the time to, we'll spend it on some small improvement and documentation. We got some feedback, especially with regards of the plugin system, how it can be improved, and some improvements of the dev mode are already made. We're just mentioning those as ongoing projects that require some improvement. Now I'm passing the ball to I think Sebastian.
Yep, that's
to
right.
talk about the middleware.
So yeah, I'm gonna my main goal is to introduce the middleware project and then to kind of mention briefly the future of it and what we're gonna do with it. Currently the middleware is an application that runs together with the Node application, and it provides a series of endpoints, which consists of we could say it's an aggregated sort of layer of data that the node provides, but with additional features on top of it, like filtering capabilities and being able to retrieve information easily for the users to be able to use that information easily and fast as well. So the way we expose these features is through HTTP endpoints that are queryable. So you can specify filters, you can specify ranges of 2 given generations to obtain data from that range. And you have also several different ways of filtering depending on the endpoint. You can filter by accounts and so on. All these endpoints, or at least the endpoints that return lists of data, are all paginated as well. So if you want like all the accounts for all of the transactions for a specific account, you're gonna get them in a paginated way. With 100 records maximum. And if you want all of the records, you'll need to go through them so that you do not get, so the amount of data you get is limited and you do not run over the capacity of the server. It's also versioned. So all the endpoints are prefixed with the version number. At least from version 2 onwards. Version 1 wasn't that way, wasn't prefixed by the version. But since version 2, which is the version that we're at right now, we intend to keep doing this. And then it's also live in a way that it's up to date, or at least we try to. It's up to date with the latest node block. So, and if the node updates and there's a fork, then the data is also updated in the middleware itself. And for some users, there's also a very useful feature, which is the WebSockets, which provides live changes that happen. And you can subscribe to just new blocks that happen, micro blocks or key blocks. And you can also subscribe to new transactions, or you can even filter by what kind of transactions you want to subscribe to. For instance, I want to subscribe to, I want to receive all the transactions for a given account, and you would only receive that. So that's pretty much what the middleware does right now. And then next slide, please. In terms of the different sets of endpoints that we have, we support key blocks, micro blocks, and transactions, which the node already does, but without all of these filtering capabilities. So that this is the kind of the value added from the middleware. Then there's endpoints for contracts, channels, oracles, names, internal transfers that happen. For instance, refunds or names or different names for oracles expiring and getting different balances of different accounts, money transferred without any explicit transaction created by user. So those would be the internal transfers. We also have stats endpoints we provide for each generation in particular, provides things like activated oracles, activated channels, and kind of like counters to see where what went on that specific generation. Then there's an activities endpoint, which was added not long ago, where you can filter by a specific account, and it will give you all of the transactions, all of the transfers, and everything related to that specific account. And then there's lots of endpoints for the AEXN tokens. So for now, it would be AEX9 and AEX141. Where you can list several different things like balances for specific accounts, or all of the tokens for a specific contract, and so on. So that's pretty much what the middleware does right now. And then what we're going to do in the future, what we're already working on, is several different things. From the feature side, we're going to be adding better filtering capabilities to the new activities endpoint. So not just giving you all the activities related to an account, but maybe being able to filter up what kind of activities you want. And then, well, when the new support for Hyperchains is added, we're going to be supporting that as well. And then usually as we kind of start the quarter, new features come up from specific users that we want to they want to have and features that make sense. So we also implement a few improvements for the endpoints or even bug fixes as well. So we're going to be doing that as well. And then there's a few restructurings that we want to do. We want to get rid of the V1 version, which has lots of limitations and a few performance bottlenecks. So we're going to get rid of that. We're going to announce it first, of course. Then we're going to be profiling different different computations that happen on the middleware itself, like how much time something takes, or how much, for instance, a block takes to sync, and work on improving those things. And yeah, related to that, we also want to be able to expose that information to the outside world. And we're doing that. We started working on exposing different metrics. We're using telemetry with a couple of other Elixir libraries to do that. And then in regards to planning and documentation, we're going to need to plan what we want for V3, because we also want to get rid of V2 at some point, which has a few smaller, but still has a few limitations that we want to get rid of and correct in the V3 version. Then we're going to revisit the Swagger documentation, make sure it's updated. And then there's also the architecture documentation on the repo itself, which is quite outdated, and we haven't updated it. So we're going to work on that as well, so that people that want to contribute to the middleware can also do that easily by reading the architecture docs. And yeah, we want to welcome the community to be able to also contribute to the middleware and interact with it and so on. So that's the plan. And yeah, I think that's it for middleware. I don't know if anyone else want to add anything.
We can move on.
Okay.
Now I pass the ball to Metin, who is going to talk about the JavaScript SDK.
Hi. So after I joined during the last summer, I worked on several applications that talk to the Eternity blockchain. And with time, I started finding use cases which do not really fit the current JavaScript SDK. Because they have different requirements. So we started thinking about developing a new SDK, which is currently, like, initially at least, to be like a research project, but then maybe even become more widespread and replace the old one. We'll see. So the biggest challenge we've had with the current SDK is that it is too monolithic, and it has very specific flow. So you have to obey some rules in order to use it, and we had use cases that basically required other things. This monolithic object-oriented design didn't really fit our needs, and we started thinking about, and some colleagues even implementing parts of it in a different way, which is not object-oriented and is more modular, so we can swap parts basically and use some of them for some projects and not all of them. Probably our initial needs are for development purposes. For example, for Hyperchains, we will probably need to have a different, a very basic wallet which can do things that are not possible currently with the current wallets. For example, having several accounts in the same time and other things. So this is it. We are on the Craig and Peter have been working on this for almost a year, and currently I'm thinking about combining all the efforts into a higher level package, so to say, which can be used for this purpose. I guess that's it.
Okay, great. And that was the last point that we wanted to share. Now I think it's questions time. Guys, can you see the chat? The first question is middleware related question. Let me read it. Is it necessary to know Elixir to be able to code the endpoints or to do anything else with it directly?
I can answer that. No, it's language agnostic. You just need to make an HTTP request using your preferred language.
The second one is JavaScript SDK related question. If it was possible already before to have several sub accounts in the base app, why is it difficult to have the same feature on Superhero Wallet, for example? I think this is mostly a Superhero Wallet question, not a JavaScript one.
Yeah, it's I don't know. I mean, it's a matter of maybe politics and also a matter of not wanting to actually destroy Superhero, because for some experimental features we actually want to experiment. So yeah.
Yeah, it's also it's worth noting that the base app indeed allows to have sub accounts, but those all are connected to the same phrase, same seed phrase.
Yeah, I'm not talking about sub accounts, but totally different accounts and being able to swap between them.
Yeah, and having a couple of different seed phrases. So this is different from sub accounts, which are, well, a result of the same seed phrase, essentially. Okay, the third question is Hyperchains related question. Could clogging the chow chain congest the parent chain in the case of Bitcoin? The more chow chains secure themselves with Bitcoin, the less likely the parent chain will continue working. So if we have a lot of chow chains, they will fight for transaction space, for space in blocks, so they can do commitments. And if we have hundreds and thousands of chow chains that all fight for the same amount of space in blocks, yes, that's going to be an issue. And this is really easily solved by having chow chains attached not directly to the same parent chain, but having chow chains attaching to another chow chain that is talking to the parent chain. So if you have 100 chow chains, it's totally safe, trademark, to have almost all of them being attached to the same chow chain that is talking to the Bitcoin parent chain. Furthermore, saying that we'll have a feature complete hyperchain doesn't mean that the hyperchain project is done, finished, and there's nothing else to be done. Quite the contrary, there will be a lot of optimization points. And one of the hottest topic there would be that currently every staking validator is required to do a commitment on every parent chain block. And this is simply not, well, it requires a lot of commitments on the parent chain, and this is not optimal, and this can be optimized. So this is going to free quite some space even on the parent chain for even more chow chains being attached to the same parent chain. So the idea is not everyone attaching to Bitcoin. On the contrary, we can have one Chow chain that is attached to Bitcoin, and all Chow chains can be attached to it, and even more Chow chains can be attached to those Chow chains which is attached to the Chow chain which is attached. So you can form a tree structure, really. And the idea is that you don't lose security over the traversal of the tree. And even if you have a really small chain, that doesn't make sense to spend a lot of fees on Bitcoin. You can still be safe attaching to another Chow chain that is simply cheaper than Bitcoin, but still attached to Bitcoin. Question number 4. Where the new JavaScript SDK research can be tracked? Will the new SDK be supporting more platforms than just the JavaScript one? The JavaScript alone? Matthew?
Yeah, I will start by the second part of the question. There is already some progress being done by Sean in Swift. I hope that that's an interesting question. I hope that we can do that at one point. Like supports many languages, or maybe even like make it so that it is easy to write SDKs in many languages because they follow the same patterns. Regarding the progress, we probably the easiest would be if you search the Eternity organization on GitHub by language TypeScript. So there are several projects there, mostly UI and like more specific regarding specific problems we're solving. For example, the generalized UI, generalized accounts UI, which we are currently developing. They currently still use the current SDK, but they will be the probably the testing ground for a new SDK with time. So, and also, of course, when we start this repository, which will be the new one. Also, there is a project called Vanilla, which is also in the Eternity organization. It is developed by Craig and Peter, and they have published it. They are already using it. It is very simple yet, but it's completely possible that we are going to base the new SDK on that.
The next question, what are the use cases for garbage collection in smart contract development? Is it related to oracles feeding data to the chain? I guess, Ulf?
No, so the garbage collection is more about saving disk space on your own node. And it's not something that is accessible from, for example, Sophia contracts. And ideally, you will configure your node so that well, whatever you want to use it for, you are keeping enough history that you can actually find all the data you need. Normally, I would say most applications are worried about or are concerned about the data in the top and don't necessarily want to go back 1,000 generations in the past. But hey, if you're tracking your own account or whatever and want to see full transaction histories, then you might want to do that. A thing that we want to look into in the future is, given that we do full garbage collection, you might want to extend the sync protocol so that a syncing node can go to its peers and request the live state at a certain height and simply sync up to that and not worry about the state that came before that height. And that should radically shorten the sync time.
Okay, next question is, where can detailed reports on the progress of grant applications be found? And that's quite easy. On the forum, there is a section called grant applications where all the Eternity Crypto Foundation grants are. all applications are there, and their reports are living there.
Yes, and if you look at the categories in the top bar in the forum, you will find Eternity Crypto Foundation there. And under there, you find grant applications, roadmaps, and announcements, things like that. So,
another question: how Hyperchains can improve the energy consumption problems of the Bitcoin blockchain? And I don't think they can. The idea of Hyperchains is not that we change anything on the parent chain, especially if the parent chain is Bitcoin. On the contrary, the idea of Hyperchains is to have as many Chow chains as needed, and they all share the same security of the parent chain. Meaning that you don't need to have all the miners that Bitcoin has to be secure, but rather you need to have one secure parent chain to connect to, or it could be either a Chow chain itself or Bitcoin itself. So even if you have a small use case where you don't want to attract a lot of miners at the moment, you can still draw security from the parent chain. This again doesn't change the energy consumption of the parent chain itself. That energy consumption is actually beneficial, as this is the source of security of the Bitcoin chain. The amount of miners that they're there. Next question is, what issues have been identified with the plugin system? I don't know who wants to answer this. I know Sean was doing some refactoring with regards of internal API.
So one thing we, well, actually Sean requested was that part of the what was in the DevMode plugin should be moved integrated into the core, and that this is essentially the on-demand block production that was part of the DevMode plugin. It is now part of the core software, so you don't actually have to have a plugin to access that. All you have to do is enable DevMode, and then you can configure, for example, automatic block production, which means that anytime a transaction is pushed to the mempool in your DevMode system, it will produce blocks to bring that transaction on chain. Another thing, as we started getting more sophisticated DevMode plugin functionality, it was necessary, or at least desirable, to bring in dependencies, libraries that the plugin could use. And there were some issues with the loading or handling of the dependent libraries. So I've rewritten that so that now if you're developing a plugin, for one thing, there is a rebar plugin that you can install into your build system, and it can automatically build an archive that you just copy into the plugins subdirectory of the node, and it will unpack it, and all the dependencies are going to be in it. So that should be vastly simplify the development and loading of complex plugins. And also, I've done some improvements on the API side, accessing configuration data, accessing your own configuration data for the plugin, things like that. And for the DevMode plugin, there was a request to be able to precede accounts, and this is sort of waiting for approval in a PR, but it's pretty much ready. So we should get to that, well, shortly.
Okay, another question. What are the prerequisites for learning Sophia smart contract language? Is it different from Solidity? And I don't know who wants to answer that.
I thought you wanted to.
Do you want me to? Okay. So it's different, and it's different in a good way. There is nothing. There are a lot of expressions that are made explicit by design. So every time you want to change something in the state of the contract, this is made explicit, and there is no way of you missing it. The idea of that is that you don't make mistakes, and the code is guiding you towards it being safe. The goal of the Sophia syntax is that you don't make mistakes, voluntary or involuntary, and let's say that makes it quite unique in that space.
So
I don't know
yeah,
if someone wants to add something.
it helps if you are familiar with functional programming languages, but it's not a requirement. You can learn how to use it otherwise, even without that. It will feel perhaps a little bit more familiar if you've seen functional programming languages before. But the thing is, given the context of contract programming, they really need to be context insensitive anyway, which is a perfect fit for functional programming languages. So I think what you should do is dive into examples and then find an example that you can play around with and modify. I think you will find that it's quite easy.
So I would add to that obviously, as well as learning how to write the Sophia contracts, you need to be able to get them onto a node and run them. And there are a bunch of different ways to do that today. It's something that the DevMode plugin we've already talked about is very much aimed at making that process easier, so that you can create smart contracts in a plugin and deploy them and test them in a dev environment. But there are other tools as well. There's a tool called AE Studio, which people use, and even VS Code plugins for syntax highlighting Sophia and so on. So, but it's an area that is always being improved, the ability to fully end-to-end develop smart contracts and deploy them. Yeah.
The next question is for DevMode, and I'm afraid we also already answered that. What can we use DevMode for? Is it related to smart contract development? Do you want to add something?
Yes. So, for example, AE Project and AE Studio do use the DevMode plugin. For faster turnaround. So the main thing with DevMode is that you don't have to wait there is not necessarily a 3-second interval between micro blocks. So basically blocks can be created instantly, which makes it so much easier to test things, to deploy, and AE Studio and AE Project were kind of okay when you had to deploy to testnet, but it still took several seconds before you could test your contract. So this is now much faster with the DevMode. So that's the main feature of it.
The next question is for the middleware. Can the middleware also be used for NFTs?
Yes, there were lots of work in regard to that. The NFTs are specified by the standard AEX 141. You can check that on the Aeternity GitHub repo. And yeah, besides checking the standard and knowing better how it works, there are some endpoints that you can find in the middleware to list the contracts, the NFT contracts, which are the collections, right? So you can also look for a specific collection, which tokens, which NFTs were minted, who are the owners of these tokens, and what were the transactions as well, the transfers of these tokens. So there are plenty of endpoints that you can use to develop your NFT app. solution, like a marketplace. And going back to the first question, I haven't commented, but if your question is about the cursor, because you can make the HTTP request with any language, right? But if you find there a cursor and you're asking that because it's encoded, you don't need to decode this cursor. It's only used for the pagination purpose. So this cursor is used to get the next page for any point that's paginated in the middleware, and that's all.
Okay, next question is there already a way for us to play around with Hyperchains? Where can we see it? And so you can play around. We have a running testnet, and it had been running for a few months now. At this point, it's not producing or consuming commitments, but it's still drawing entropy from the parent chain. And you can use it as every eternity blockchain, like every instance of the eternity blockchain. From the user's perspective, it's quite the same. What you can actually do is you can try the staking and staking part. So basically, it's a delegated proof of stake, and you can become a, well, not staker, but delegate. You can delegate your staking power to the one of the three stakers that we have. So currently you can go to, I don't know where to write the URL, but you can go to the forum and fetch the URL, and you can see the different staking power of different stakers. You can yourself become a staker. There is delegate. There is a running faucet, so you can receive 5 Hyperchain coins, and then you can stake them to whatever staker you want to support, or maybe all 3 of those. What else? You cannot. You can still start the Hyperchain of your own, but you have to prepare the setup yourself, which at this point it's not quite trivial. So soonish we'll have a Docker Compose setup. So you simply have to run one command to set up your own local Hyperchain and another to start the whole batteries included setup. So if you really want to try something, you can fetch the latest release and set up the Hyperchain yourself, and it's going to be working. But that's not trivial still. The next question is, what does entropy mean in the context of a parent chain? Is there another way to describe it? So the entropy is required for the Chow chain, not the parent chain. The Chow chain currently, so the goal for the Hyperchains is to make it as extendable as possible and to be able for anyone to spawn a specific Hyperchain that fulfills their needs. So as much as possible of the consensus logic is moved to a Sophia smart contract. So all this staking and staking delegates is a contract, and the leader election itself is a smart contract. And as such, it must be fully deterministic. So if my machine elects a leader, your machine should elect the same leader. But still, if you have a set of staking validators and their staking power, we don't know the next leader to be known in advance. So what we do is we use, entropy is a really good word for that. If you want, we could be using chows, but entropy is much better. So depending on the stake, you can consider it as a lottery. As much staking power you have, this is the amount of lottery tickets you have. So the more staking power, the more lottery tickets you have. And but then someone has to actually win the lottery, and we don't know who is going to be at the moment. and we draw that from the parent chain. So we need something random, but random that is fully deterministic, which is self-contradictory in its nature. So what we do is we fetch the parent chain's block hash, which is fully deterministic at the point of election of the child leader, but also unpredictable before that. So we get a random hash from the parent chain, and we use that as a source of entropy in the child chain election process. So who wins the lottery depends on the parent chain's key block hash or block hash. Then the next question is what is a state channel market? And I pass the ball to Ulf.
Okay, yes. So how much time do I have? So state channels are a way to go off chain. You can and have a dialogue, a one-to-one with another participant. And basically you take money from your account and load those into the state channel. And then you can transact using over an encrypted communication line, and you have to co-sign every transaction. Every time you update the state, you can send tokens to each other, you can call contracts, whatever, and the way you agree is that both participants sign every update of the shared state, and then you can later on close the state channel and move the funds back to the chain, to your accounts. A limitation, of course, it's that it's one-to-one. And the main reason for that is that if you don't agree on how to close the state channel, you go into dispute mode. And the more actors are involved in the dispute mode, the more complicated it gets. If there are only two, then it's only half complicated. In the state channel market scenario, you create a state channel to a hub. So, for example, vendors could create state channels to that hub, and customers could create state channels to the hub. And then you just keep that state channel up. You can close it down and just reactivate it, and it stays alive. So you can have a state channel active forever, basically, to the hub. And what the hub can do is that it can forward payments very quickly. So within tens of milliseconds, you can pay a vendor. You from your state channel, and the hub forwards the payment, and it's done using what's called a hash lock, which is essentially like a two-phase commit. So it's pretty much atomic. If the so this would allow you to do to scale up with state channels and do ad hoc payments to customers without having to negotiate a separate state channel to that individual. So that's what state channel markets are. And there is a test suite for the basic functionality, and there is a prototype that I showed at the AE Universe 2 conference.
Okay, next question. Are there already any use cases of generalized accounts? Is it related to the new pay for transaction feature in the Superhero wallet? And now we are working on thin ice, and I don't know what is yet announced, but there is a project that uses generalized accounts and paying for transactions to set up new accounts, but I don't know what is announced at this point. If it's not announced, I should better shut up. I really don't know. Eric, if you know if this is announced, please speak up.
Yeah, it's probably not announced yet, but I think you can talk about this feature that is in the Superhero wallet already. I've seen that it's implemented.
Well, I haven't used it myself, or rather, I had used the unannounced project this way, but I didn't need superhero to be. The idea is that you produce a transaction and you start with an empty account. You don't have any coins in your account, or I, as a service provider, can authorize your transaction, so I pay the fees for your transaction. And this is actively being used for an upcoming project. So if you want to cover the fees for someone else, this allows you to do so. And it has really neat use cases, but we're on thin ice. I don't want to spoil. Whoever is developing this, they'll announce themselves. But the paying for transaction is part of the aeternity protocol for a few years now, and it's alive on mainnet. So you can cover. So imagine you have a use case where you want to onboard a lot of new users, and they start with empty accounts, and they want to upgrade those to generalized accounts. So they use different authentication methods, and they cannot do that because those accounts are still empty. So how do you do that? And stay tuned. Someone is going to announce it probably soon.
Okay, I think we're good. There's no more questions that I'm seeing anymore.
To share something else.
Mhm.
There is another team member, Greg Everett, who is not here with us at the moment, and he and his partner are building a fully decentralized on-chain trading platform. But he wasn't able to join us today. So expect in the following few days a really neat video about it on the forum.
Nice, nice.
Also, if you guys are interested about the new SDK, they will probably mention things about it there.
But yeah, that's what I want to share. Stay tuned for the Craig's video about a fully on-chain trading platform.
Okay, I guess the hour is up, more or less.
Yeah, Eric? Well, that's awkward.